Today's topic is combination. A combination is a collection of objects in no particular order. Illustration. Listed below are the possible samples of two letters from the letters of the word yes. YE, EY, YS, SY, ES, SE. If we are solving for the permutations of the letters of the word yes taken two at a time, then there are 6 permutations. 1, 2, 3, 4, 5, 6. The order in which the letters are listed is important. Let us list the letters again. YE, EY, YS, SY, ES, SE. In combination, YE and EY are considered as only one combination. YS and SY are also considered as one combination. So 2. ES and SE are also considered as only one combination. So 3. There are only 3 combinations. The order in which the letters are listed is not important in combination. The combination formula. In this combination formula, n is equal to the number of elements in the set. The elements can be objects, numbers, or even people. R is equal to the number of choosing objects or things or people from the set. But the formula is read as the combination of n objects taken r at a time is equal to n factorial over r factorial times n minus r factorial. Example number 1. In how many ways can a committee of 4 be chosen from a group of 15 students? There are a total number of 15 students, so n is equal to 15. It says here committee of 4, so r is equal to 4. So this is a combination of 15 students taken 4 at a time. The formula is the combination of n objects taken r at a time is equal to n factorial over r factorial times n minus r factorial. Replace n by 15 and r by 4. So this is equal to 15 factorial over 4 factorial times the 15 minus 4 factorial. This is now equal to 15 factorial over 4 factorial times 11 factorial. 11 factorial because 15 minus 4 is 11, so 11 factorial. 15 factorial is equal to 15 times 14 times 13 times 12 times 11 factorial. We stop at 11 factorial so that we can cancel 11 factorial with 11 factorial in the denominator. And then 4 factorial is equal to 4 times 3 times 2 times 1. So we have 15 times 14 times 13 times 12 times 11 factorial, 4 times 3 times 2 times 1 times 11 factorial. Cancel 11 factorial in the numerator with 11 factorial in the denominator. 4 times 3 is 12. You cancel 4 and 3, and then with 12 in the numerator, so cancel, and then cancel 2 in the denominator with 14 in the numerator. This becomes 7, and then 15 times 7 times 13 divided by 1 is equal to 1,365. So there are 1,365 ways. Example number 2. In how many ways can you invite 3 of your 10 friends to dinner? N is equal to 10, R is equal to 3. The formula is the combination of n objects taken r at a time is equal to n factorial over r factorial times n minus r factorial. Replace n by 10 and r by 3. So, this is now equal to 10 factorial over 3 factorial times the 10 minus 3 factorial. This is equal to 10 factorial over 3 factorial times 7 factorial. 10 factorial is equal to 10 times 9 times 8 times 7 factorial. We stop at 7 factorial so that we can cancel the 7 factorial in the numerator with the 7 factorial in the denominator. And then 3 factorial is equal to 3 times 2 times 1. So we have 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial. Cancel 7 factorial in the numerator with 7 factorial in the denominator. And then cancel 9 in the numerator with 3 in the denominator. This becomes 3. And then cancel 8 in the numerator with 2 in the denominator. This becomes 4. 10 times 3 times 4 divided by 1 is equal to 120. So there are 120 ways. Example number 3. How many line segments can be formed by 4 distinct points? Let us draw 4 distinct points. 1, 2, 3, 4. Let us connect the points by line segments. Let us count the line segments. 1, 2, 3, 4, 5, 6. So there are 6 line segments. Let us solve the same problem by using the combination formula. In the problem, n is equal to 4. A line segment is a part of a line that connects 2 distinct points. Therefore, the total number of line segments that can be drawn is the combination of 4 points taken 2 at a time. So R is equal to 2. The combination formula is the combination of n objects taken r at a time is equal to n factorial over r factorial times n minus r factorial. Replace the n by 4 and r by 2. So, this is now equal to 4 factorial over 2 factorial times 4 minus 2 factorial. This is now equal to 4 factorial over 2 factorial times 2 factorial. This is now equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Cancel 1 in the numerator with 1 in the denominator, 2 in the numerator with 2 in the denominator, 4 in the numerator with 2 in the denominator. This becomes 2. 2 times 3 divided by 1 is equal to 6. So, there are 6 line segments. Suppose instead of 4 distinct points, there are 20 distinct points. If we are going to draw 20 distinct points and then connect the points with line segments, it will be very difficult to count the number of line segments. So we are going to use the formula. In this case, n is equal to 20, r is still equal to 2. So replace the n by 20 and then r is still by 2. So this is now equal to 20 factorial over 2 factorial times the 20 minus 2 factorial. This is now equal to 20 factorial over 2 factorial times 18 factorial. 18 factorial because 20 minus 2 is equal to 18. So 18 factorial. So this is now equal to 20 times 19 times 18 factorial. We stop at 18 factorial so that we can cancel 18 factorial with 18 factorial in the denominator. And then 2 factorial is 2 times 1. So, cancel 18 factorial in the numerator with 18 factorial in the denominator. Cancel 20 in the numerator with 2 in the denominator. This becomes 10. 10 times 19 divided by 1 is equal to 190. So there are 190 line segments.